So I've just started the recording. Okay, I want to thank everybody for phoning in to this second session. This is our BIM course for IBIU. It's course number 2 of 13. And we're going to be focusing on BIM Goals and BIM Potential. We're going to be expanding on some of the topics that were discussed in the first session and then setting up for subsequent sessions. So just a reminder to everybody that IBI Group is a registered provider with the American Institute of Architects, and therefore this course has been registered for one learning unit that could be used against your continuing education, whether you are an AIA registered architect or whether you're registered in other Canadian provincial associations, the United Kingdom, etc. For those who are AIA, if you could please, in the questions box, enter your AIA number at any point throughout this webinar. In so doing, it puts your number beside your name, and when we pull down the registry of the course and to do the certificates, we can automatically enter your numbers to the AIA. If you're in a room with multiple people, make sure on the sign-in sheet to include your AIA number beside your name. So again, this is copywritten by IBI Group. Today we're going to outline the possibilities that exist within BIM, focus on how they can be selected, scaled, applied, etc. We're going to talk about the goals in general, the approach of what I'm calling the BIM cookbook, and how to go about getting your, quote, recipe ready for use. We'll go through that. The learning objectives, talk about the uses. And again, there are multiple BIM uses, but really it's why would we BIM and what could we do with a BIM? The concept of the cookbook, BIM goals in respect to scope, schedule, and budget. So understanding how to impact your project based on how we BIM, and then the execution of a BIM execution plan. Again, not into in-depth details, but how it's supposed to drive from front end to back end. So a very quick recap, all of our subsequent BIM course, BIM sessions, we're going to do a quick recap of some of the fundamental slides from the BIM Fundamentals course. So just a reminder, BIM is both a verb and a noun. So the process of building information modeling, or often you might hear building information management as well, generation and management of digital representations of physical and functional characteristics of places. You could also say it's look at all of our physical assets across the globe in our buildings and our infrastructure, and it's the assembly of those assets relative to each other, rich with metadata. BIM, the noun, are files that can be exchanged or networked to support decision making about a place. Current BIM software current softwares vary depending on use, whether it's for individuals or businesses, agencies, and they can be used for designing, constructing, operating, or any combination thereof. It can be applied in a scaled manner, and from the perspective of IBI, whether it's a building, a system, or an infrastructure, so the I, the B, or the I, it can apply in some form or another. And then collaboration and planning, for me, are probably the most critical pieces when applying BIM to a project. So planning in that, what are you doing and why are you doing it? And collaboration, knowing that there's more beyond just what's happening inside my lone computer, whether you're collaborating within an office, multiple offices, multiple entities, etc. Geometry plus data equals BIM. That's all the math is. So I like showing this slide because it's a wall, a window, etc., or it's a blob that could represent a piece of equipment, a lighting fixture, a street light, a catch basin, whatever the asset is within the built environment. There's some type of information. That information is usually applied through the use of a BIM authoring tool. Now, I don't get software specific in this course, in this session, sorry, but in the first one we did have a software slide, so you can have a BIM authoring tool that is your Revit, your EcoSim, your AutoCAD, Civil 3D, Vectorworks, Plant 3D, Open Plant, you name it. So there's various types of software out there that allow you to model components that are rich with information. The amount of information is scalable depending on the intended use or the BIM goal that you're trying to achieve on the project. The same equation works with vast linear infrastructure. So this is a slide that I've used in the UK previously. And if you think from the building perspective, you're modeling elements in a building. From a linear infrastructure perspective, modeling the element or the curve at the bottom right, there's not much to that from a modeling perspective, but it's interrelation between it and the entity of the bridge versus the facility of the roadway versus the complex infrastructure of the network. So that interrelationship is all about the metadata that one element is associated to. And it's all brought together into unison across the vast network. We have life cycle information. So when I show this, I'll say, yes, I place something in the model. And when it's life cycle or focusing more on asset management, we want to represent the physical characteristics of the item. So what's its Cartesian coordinates? It's X, Y, Z. But then its unique identifier springboards the BIM model to other forms of information, whether it's drawings that come from the model itself, parallel intelligent schematics, specifications, operations and maintenance guidance and documents that are brought throughout the duration of the project, or possibly operational or facility management screens that are used to run the building. And all of that is interrelated based on a unique identifier attached to an object. We have some projects we're looking at, if you've heard the term RFID, radio frequency identifiers. You attach barcodes to the assets, and if the assets are mobile in real life, then that BIM unique identifier can have a relationship to a barcode on the actual physical asset, and therefore you have a relationship between where something is represented in a BIM model to where it's actually physically located in the real space. So there's a lot of possibility when we get into BIM asset management. So with all of that said, that was a very, very brief recap of the last session. BIM as a cookbook. I did discuss this, but this is kind of the premise of what I want to talk about today. BIM can be very, very complex, but I like to describe it as just think of when you're cooking and whatever you're eating, it's just a collection of ingredients. That's all BIM is. And what you collect can be assembled in various types of recipes. And I describe it as you have some recipes that are good, efficient, repeatable, ones that you want to go back to over and over and over again. And then you have some recipes that are just ones that you would want to never use again and never have to repeat unless you're forced to due to client requirements. And that's something to keep in mind because the vastness of BIM really takes that into account where there are so many different ways that you can apply BIM. And when you look at why you would BIM, I would argue that there really is no right answer, but the answer has to be fit for purpose. It has to be thought about. There has to be a reason as to why. So, think about that as I'm going through the context of the following slides to really purposefully place why, just why really is the question. What is that recipe where we said, you know what, we want to do something IBI wide. So if we have the ability to say this is the one IBI way when it comes to BIM, what would that be? And is there a one IBI way? Is there a reason that we would do BIM by default? And then what are all the other possible value adds? So think of that. So what can we do? So when we look at BIM, I'll just go to the next slide here. there almost always is some type of modeling and design work associated with BIM. And I say almost always because if we're working in the purely asset management realm, it's really about the metadata. So what information that we can harness. But the information is always coming from somewhere. So use modeling in a loose term because there could be other forms of models that in the work you do every day, you might not consider them or think of them as models. But there's some. And in North America, we have what's called the Penn State BIM Execution Plan that defined a series of BIM uses. And it's essentially why you would model. In other parts of the world, I know in the UK, BS 1192, or its companion documents, also have looked to kind of describe what are the reasons for BIMing. And that's what I'm going to outline here. So I've termed this kind of like my wheel of BIM as well. But I've looked and I said, okay, why BIM? And these base BIM uses, we said if we turned on a model today using any type of BIM authoring tool, these are the kind of things that we would do by default. And we're going to go into detail for each one of these. These typical BIM uses are the things you hear. So what does that mean when I say, okay, great, we can clash detect. Do I have to? Do I have to schedule simulate? What impact does that have? And why would I do that? And then there's other uses that could be overwhelming, that could be completely irrelevant, or that could be at the very core of a specific RFP you're trying to reply to. So that's something to keep in mind as we go through these. And you know, I'm going to go through each one of these now, and you'll see that some of them are maybe design orientated, some of them are more construction orientated, and then maybe there's an easier line to divide. But then when you're on a DB project or a P3 and design and construction are all convoluted together, well, where's the line there? And how do you manage and mitigate that? So let's start with the model. When we look at BIM models, I always look, so you can model as little or as much as you need to. And I've always been asked, you know, do we want to model the flashing, the kink of the flashing, the membrane going down the parapet wall? Yes, no, probably not. Think about why you would model the things you would model. The term LOD, and I have a slide about it later, but it's a level of detail. And it's, again, it's a North American term, so for those who are calling in from other parts of the world, it's really attempted to divide or delineate how much detail. And I kind of rationalize it when it starts at LOD 100 being schematic, 200 about 60% design development, 300 construction documents, and then anything above is beyond design, so either fit for installation, construction, or operation. And what I try to sell or just ingrain is LOD 300 is that level of detail, it's that comfort level where we say if we approach that, we'll have enough in our model in order to produce the drawings we need to produce. And that gives us enough detail to fulfill several of these other BIM uses, or at least to have the starting point to then think about some of these other uses. Drawings and schedules, so it's one of those, these are the ones we always have to do. So the biggest change, and for those who haven't started using tools like Revit, that the drawings come out of the model represents what's going to be in the drawings. So, you know, tools like Revit allow you to work in a 2D mode, but really you're affecting 3D, and it's all about the third dimension. So getting over that initial hump is usually the best starting point. And I love describing, you know, when you compare from the 2D world, if you want to draw a wall, you draw a line, you offset it, you have a wall. You can have intelligent 2D tools that says, you know what, I'm going to draw the offset line at the same time. So it's going to be 6 inches apart or 150 millimeters apart. Well, now in the Revit world, you draw the wall, you've got to pick the wall type, you have to say how high it's going to be or whether it's going to go up to the next level, and then you draw it. So when you're drawing in the 2D world of Revit or any other BIM authoring tool, you have to be cognizant of that third dimension. The schedules I'm weary to say they're a byproduct of the model, but if you're using the BIM authoring tools intelligently, so I'm in Civil 3D, I've placed the pipe network, I've placed my fittings and any valves or catch basins associated to the network, and then I want to have a list of items part of that pipe network, I can facilitate that because I've modeled correctly. In Revit, if I've placed my beams and my columns using the right tools, meaning I haven't placed the column, rotated it 90 degrees and called it a beam. I use that as an example because people often chuckle and say, why would you do that? But I've seen that before. So as long as you use columns for columns, beams for beams, I can suddenly get a list of how many columns and how many beams. So some fundamentals from that perspective. The other thing with drawings and schedules is no matter how much BIM we want to do, in this day and age today, in any jurisdiction across the globe, drawings and schedules are still part of the fundamental contractual obligation in the AEC industry. I've been on instances where I've had model turnovers that have been attempted, and for some part they work, for other parts they don't. So almost always there's some form of a drawing and schedule. Therefore, from a BIM implementation perspective, they've got to be able to do it, or we will fail. So that's a lot of the work that's done to make sure that's facilitated. Visualization. Now, I want to stress this because it is by no means a push button. You don't push a button and get an advanced visualization. There's many kinds you can generate, still renderings to animations, level of detail and quality is flexible. So I say that because let's say you said, do a push button. Well, I can print my screen and paste it in an email, and it'll allow you to see an image of the model that I was working on. That is by no means an advanced visualization. It's not an intermediate visualization. It's a rudimentary visualization, yet it is something that could be done. We have across IBI a one visualization network, and I'm going to interlude of my wheel of BIM here now. I'm going to talk about this also in the next session, but I wanted to bring this to the attention here in this BIM session. So there's various levels of visualization that can be done. Level 3 and up usually take far more time, far more effort, require planning, may require manipulation of the models. So a good example is, let's say I'm doing LOD 300, or I have the intention to do that. Yet I'm only at 60%. My model is, design development, 60% right, 40% not wholly thought of yet, whatever the case is. But I want to have a photorealistic rendering. There's a lot of effort to get from my 60% model to photorealism. Yet if I'm doing a massing study, if you look at that example there, that could be activate the solar shade in the BIM authoring tool, export a JPEG, what you see is what you get. So there's various levels as you go from 1 to 5. And a little bit on the virtual reality, there's quite a bit that can be done. It's an exciting realm. So we have a team of advanced specialists working with the Oculus Rift, or some other technologies for virtual goggles, which are real exciting. We have the ability to 3D print and laser cut, but all of that requires taking the BIM model in the current state, prepping it in one form or another, and then generating the output. So I wanted to make sure that there's an understanding here that when we plan for visualization output on a BIM project, we have to make sure that it is planned correctly, we have the right people at play, the right schedule, scope, budget, etc. That's a prelude to the latter half of this presentation. Design and construction review. For me, in my history, that's been the biggest byproduct. You got a model, pull it up on the screen, let's drive through it, have a look around, gain an understanding, make sure that we're seeing the design without having to just shuffle through paper. Hopefully identify problems, errors, facilitate markup, interact, and virtually communicate either with our construction teams or an extended design team. So it's a very powerful tool, and often it can be done live in the BIM tool itself. So, pop open Revit, drive, pop open Civil 3D, drive through the view. We can bring them into formal review tools like Navisworks or Navigator, and then that usually implies a project BIM lead that's managing the process, driving through, and helping to facilitate the review sessions. So there's a lot, but it's probably the biggest, why would you do BIM? To visualize and understand and review the design in a more meaningful manner than being handed a set of drawings. So now there's the common uses. So if you go to any BIM session, you'll hear about clash detection. And there's a lot of value to that. But I need to just really stress on this. There's two ways that it can do it. Automated, you push a button, it gives you a list of clashes, or what I call a soft clash, where you find conflicts through design review sessions, identify the conflicts, and then you mitigate them accordingly. With the automated ones, it'll show you awesome ones, like, hey, there's a beam going through my column. Sorry, there's a beam going through my duct. Sorry. And when there's a beam in a duct, that's wrong. We all know that. But I have to always stress that it will not fix it. So it won't tell you to lift the building or lower the duct. If there's a beam sitting on a column, it may tell you that's a conflict, but you may have to identify that, hold on, don't tell me those because beams are supposed to sit on the columns. Or if you have handrail that's embedded inside concrete, well, you've designed it to be embedded, therefore the conflicts of the handrail post inside the concrete or the concrete curbs are not conflicts. They're designed that way. So there's that interaction that occurs with the automated routine, and then you have the ability to model reserved spaces. So some BIM authoring tools will say, put a reserved block in front of a door so that the handicap access to the door or the barrier-free access is accounted for, and anything impeding in that space will be marked as an interference. Very powerful. It allows you to identify those. Mitigation of the interferences is not done by the BIM tool, and that's something people have to understand, in that the tool can identify the clash. We can assign duct, beam hitting each other, assigned to structural and mechanical engineer. But the leadership or the management of the project has to make sure that the disciplines work through this, identify the solution, and the ramifications of the solution. And that's where BIM comes into play heavily. So if I decided, you know what, to miss that duct, I'm going to lift the building 6 inches. Seems pretty simple, but that could have some catastrophic ramifications. Or lower the duct, still catastrophic. So it'll be identified through the process of doing it all live within the model. Cost estimating, I would almost say that it's almost been a misconception in that BIM will do the cost estimate. The use is facilitation of cost estimates based on quantities derived from the model. So that's, I think, a very critical piece. The dependence there is you're modeling intelligently. So same examples, beams are beams, columns are columns, walls are walls, slabs are slabs. Seems rudimentary, but it's a very critical piece. If you use the tools as they're designed, pipes are pipes, valves are valves, etc., it'll tell me how many, so simple component counts of element types, very easy to do, and then depending on the metadata. So instead of just a wall, if in Revit I have enough family delineation so that I know that it is a concrete wall, brick wall, mason CMU wall, or I know the assembly of the wall based on wall types, it'll enhance what the estimator can then do with that information. Same with piping. If I know that it's carbon steel versus high density FRP versus stainless steel, I'll know the range of the material costs based on what's flowing within, and that'll help to drive the costing. So it's about information transfer and the amount of information. So if a BIM goal intended to fully feed our cost estimators with material quantities, that would have an impact on the project setup to make sure that there's enough metadata in the component types that are being selected in order to facilitate the information out to tools like Timberline or other cost estimating tools. Schedule simulation, this is your traditional 4D, as it's called in the industry, and often it's more suited towards construction-based activities where they can take our models and schedule them over a construction schedule. Oftentimes, because there's a BIM, we've seen this kind of bleed into the design realm saying, hey, can you do a simulation to show us? So, you know, as long as we have a model and there's proper component delineation, we can set up I don't want to say fictitious timeline, but a logical timeline to show the building growth. So you obviously see the bottom, and then the top would appear, and we can do our best guess on what components would go in what order. But I'm saying it in this manner because, you know, as designers, you know, we're not responsible for means and methods of construction or scheduling. So we want to be careful with a BIM use of this perspective to know why would we be showing a schedule simulation during the design phase of a project and ensure that we're not putting ourselves to any undue risk by facilitating that. Specifications are fun, and I think in the 3 sessions from now, I'm going to devote it specifically to that. There's a lot you can do, so that's why I'm actually giving it a whole session. But you can have components classified by various classification systems. So if you've heard of Uniformat, Uniclass, Uniclass 2, Omniclass, Master Format, and there are actually others. So it's disturbing how many classification systems there are. They're all tied in one form or another to specification systems, which can harness information pulled out of BIM models to produce project specs. So the session in 3 for now, we'll talk about that and where it works, where it doesn't, where there's challenges. From the other perspective, if we're on industrial projects, we could use specification information to drive our model. So I have experience with plant piping, and that's where that came into play, where the piping specs would drive how I model and what I can model. So a very simplistic example is if I'm using copper piping, the spec will prevent me from having a 2-meter diameter copper pipe because that cannot be made, it cannot be procured, it just does not exist. So the spec does actually a quality control of what's being put in the model before I'm even able to put it in the model itself. So there's a lot of potential there with integration with specs. And, you know, it isn't the most common, especially when BIM is starting and growing, but there is a future there with respect to harnessing that. Analysis, there's a plethora here of what could possibly happen, but in essence, it's engineers, architects, designers, etc., can link the model to some type of analytical tool. Some linkages are one way, being I'm building a model in Revit or EcoSim or Vectorworks or Civil 3D. I press a button, I export to a format, could be GBXML, it could be an iModel format, it could be STAAD compatible, it could be integrated structural model, etc. Once I'm in that format, the analytical tool can then read it and harness. Other aspects, using structural analysis as an example, I could take an analytical tool like RAM, a BIM model in Revit, and make the two talk. So if I do a structural analysis in RAM, I can feed that information to Revit, and I could use the member sizes selected in RAM to actually help me populate my model in Revit. Then if I change my member sizes in Revit, I can push back to RAM and update the analytical model and have that bi-directional communication. Sounds exciting, but just imagine, so I'm an architect by trade. I don't know what the member size should be, but if I look and say, a 450 deep beam, no, I need to lower that by a foot. I'm going to make it a 350 deep beam, or a 250, 150, whatever. What does that mean? And how do I augment and modify that? And I don't know what that does to the analysis process. So there has to be very strong communication between the element owners and the element analyzer to make sure that the proper content is both in the model and being analyzed, and that delineation of the disciplines between architectural, structural, mechanical, and electrical within a building, make sure that the components that are feeding the engineering or architectural analysis tools are making their way to those tools and back in a logical and coordinated manner with proper communication facilitated. So very important. I don't want to say riskful, but when used properly, so powerful. But again, there's got to be a lot of planning to achieve that. Fabrication. So these are now the custom or other uses that you can hear of and think, how could that work? So this example, if I have a steel model, I can feed it to a tool like Tekla. It can build some connection details and analyze the content from the model, verified by an analytical tool, and then fed directly to a steel fabricator, and then component delivered to site. Skip the drawings, skip the shop drawings, skip the detail drawings. Sounds great, but think of the risk, especially if something's wrong. So there's a lot to a BIM use of this perspective. So if the model was intended to be used for this BIM use, what I would say to that project is, okay, we've got to devise a goal. What do we want to be fabricated? And then if it was steel, then there have to be heavy watching and evaluation and quality checking and ensuring that that data going out of the model to the fabricator is pristine, so that the risk of error is as reduced as possible. Similar with procurement. In my past, I've been on projects, again on the plant projects, where we've said, we've got 10 projects that are all going to require the same amount, the same kind of pumps, and these pumps are 100 to 200,000 a piece. So if we could mass procure them in a design, build, operate project, you're just saving bottom line of the project. So that was the concept. So we had standard specs, standard components for various types of pumps built into an enterprise-wide procurement system, and as we modeled these projects, the data was fed into the system, and we knew the pump type, the location, and where we were procuring from. And they were procured en masse, therefore providing savings and ultimately, bettering the project as a whole. So, think about that. I would argue it's a much less, or a far less common BIM use, but there is that potential there, again, harnessing true and valid data housed within the model. The model itself can be used as part of an inspection process, and I've seen this with the mobility of our models. So you take our models, get them onto tablets, Android, Surface, iPad, you add metadata based on what's being inspected. You can use it for construction inspection, deficiency lists, punch lists, operational inspections, when something's ready to be maintained, visual inspection during the life cycle of an asset, and then that data is then fed back into a model or a data warehouse, and it helps to facilitate management of these assets. So whether it's during construction or during design or during operations, there is that potential there to have the model as part of the inspecting mechanisms to be utilized on site. Simulation, different from scheduling. Simulation is using the model to help to show a process or a system within a model itself. So only one example that I've worked on in my history was, it was a nuclear waste storage plant showing the emergency transfer of waste storage from tank A to tank B, for example. So we showed how it would flow from throughout the project if there was the danger of a reactor leak in one part of the project. So just imagine that on transit projects, like it's very easy to imagine simulation showing, rapid transit, showing the train going from station A to station B, what the experience would be like for the users or for the operator as they're entering and exiting the platforms. So there's various types of simulations that can be set from that perspective. Machine control, that's pretty cool. So you got a geospatially located BIM model, and you can feed that into site-controlled machines that are GPS located and have them, for example, move dirt based on cut-fill calculations and digital terrain models developed out of tools like Civil 3D or Inroads or Geopack. So pretty cool stuff. You know, again, practically imagine the risk there of if the model is wrong, what are the ramifications of that, right? So a lot of these green ones are, you got to have things done really well in order to facilitate them. Work packaging, I've seen where, you know, there's a good relationship between designers and contractors, and there's models that are being exchanged on DBs and P3s. It's just usually part of the contractual relationship. But on design bid build, if there is the turnover of digital information for information from the designer, it can then be harnessed and sliced and diced in various ways to, you know, for example, isolate the precast concrete package, isolate the steel package, isolate just the mechanical ducting, to turn over specific models and drawings to sub-trades in order to build their packaging. Health and safety planning, it's kind of similar to simulation, but this is a BIM use focused specifically on the health and safety of occupants. So here, evacuation planning of public spaces, transit platforms, office buildings, etc. So the model can be the backdrop for people movement animations to show how people would get out of a space. And then lastly, it's not save the best for last, but it's almost save the most impactful for last. And I mentioned this last time, and I'll probably stress this in every BIM session. This is where the owners are coming in, and this is finding its way in our RFPs. So asset management. From an owner's perspective, it's not about making drawings and professional liability and visualizations and how do you coordinate with contractors. It's, I have an existing complex built up with a bunch of assets that I'm operating, maybe have been for 10 years and will be for another 50 years. How can I visualize it, manage all the data, maybe have something to give to a designer for a renovation project or an add-on project, maybe link it up to other sites and other assets across a more macro network. And once I figure this out, well, why don't I infuse this into an RFP and then see how proponents respond to me? And that's where the owners are coming in. So they'll go to Autodesk conferences or Bentley conferences or Esri for GIS, hear about all the software that's out there, automatically assume, well, anybody who's going to do projects for me will be familiar with this as well. Therefore, let's build a regime around what I'm expecting to receive. And we've had a lot of RFPs, a lot coming out of the UK, major frameworks or major projects that are not only requiring, you know, the base BIM level 2, which the UK is now mandated to do, but also, since you're doing BIM, while you're modeling my assets, please include these 10 pieces of information and please provide a mechanism to turn me over the data. So it's getting compounded heavily, and what used to be, well, we could do BIM for design and we can coordinate with our contractor, all of a sudden now becomes we have to think of the life cycle, plan for that at the outset of a project, facilitate it throughout design and construction, and ensure data turnover come completion of what could be up to a 5 to 7 year cycle of construction, so design and construction. So very, I don't want to say scary, I'd rather say exciting, but it could be scary too. So this slide is actually from the Penn State plan, and what I like about this is it says, great, we've talked about all these BIM uses. These are kind of where we believe they're going to reside. So this is how they've mapped them out. There's things you're going to do during design versus construction versus operation. Depending on the nature of your project, the nature of your contract, you may just be in design or you may just be in planning, and you account accordingly. The biggest error I've seen with BIM is, okay, we're doing BIM, therefore everything around the wheel of BIM is on the table. But then you have the dialogue, but if this was not a BIM project, we would know what to do right away. So BIM shouldn't be convoluting what we know we have to do. It should be supporting and eventually making more efficient what we have to do. This is just an example I wanted to show. So, looking at all the BIM uses, my question is, how do we start? So how do we start any project, or if you've never done BIM before, how do we just start? What's the route here? So think about some of the following here. It's not about software, it's about project delivery intent. And I think that's an important piece, because oftentimes I've seen, okay, we're going to do BIM, let's get some training. Well, on which software? And then once you're trained on the software, okay, well, the limits of BIM are bound by the software I was trained on. Where when instead it's, what do we need to achieve? What's our goal? Why would we want to BIM? And what BIM uses would be used to achieve the goal? And I'll talk about goals in a moment. You don't need to do everything possible just because you're doing BIM. And if you've been on a DB or a P3 project, sometimes the notorious nature is, well, architect, engineer, I know you have Revit, so I'd like you to do A, B, C, D, E, F, G. And then you're sitting there thinking, I only need to do A and B to do what I have to do. So why do I need to do the rest? Then all of a sudden BIM becomes too expensive, overwhelming, then there's not enough people to do it, and then you just don't want to do it anymore. So that's a very critical piece as well. BIM to support your output, and then BIM to support internal growth. Define goals for the project. So you may say, I need to do drawings, and in order to do my drawings, I need to have a model, and I need to make sure I'm hitting LOD 300 so I have meaningful drawings. And you know what? Let's visualize, so let's engage the advanced BIM, the advanced Viz team, and we'll have design review sessions every month. Then you start to devise a purpose for doing the model, and then they say, you know what? If we can get some rudimentary material lists or component quantities, let's try to facilitate that as well. So you may do one or two extra things just to enhance your BIM offering in order to grow and make you well positioned for future projects. You take it step by step. Document the intent in a BIM execution plan. We have templates, we have procedures, if we have a quality management approach where we want to say everything should be planned and have your point of accountability, so have your lead. Now, for the gambit of our projects, you might be saying, well, that sounds like a lot of effort, and maybe it is the first couple of times, but I would argue that if we sat in a room and we stated our intent verbally, and then we emailed the team, in essence, that's a plan, right? So think of all this stuff as scalable to meet your project's needs, but you've got to know why you're doing what you're doing, and that's your plan. And there should be a point of accountability. So who's your go-to person if something goes wrong or something fails or you need some help or whatever the case is? There's got to be that person to go to. And we will have a subsequent session specifically on the project BIM lead alone. Ensure your intent is in alignment with scope, schedule, and budget. So BIM is heavily rooted in project delivery. BIM is not the side thing. It's very important to ensure that there is that connection point. Ensure quality is maintained or better still increased and risk is mitigated. So you've seen the McLeany curve before, I apologize, but this kind of depicts, for me, an important concept. Decision-making and change management. Stick to that, and this applies for project management as a whole, but we all know it's easier and cheaper to make changes earlier on and much harder. For example, in construction, I've already poured the wall, can we move the wall now? Well, no, it's harder to do that, etc. So the design effort, that traditional curve, compress it, shift it, make more meaningful decisions during schematic design and design development, so that when you're in construction documents, it is a much smoother flow. And for those across the globe, I know that those phases are the AIA phases, but I'm going to have a matrix to talk about the project delivery in a moment here. The other thing to think about, and again, we'll have more sessions on this specifically, is that BIM is a virtual team. So depending on the nature of the software we have, you may have a centralized database or centralized BIM, as I call it. So it's a focal point for content, great in a single office network. If there's multiple offices working on a project, we need to plan for that. So collaboration solutions exist to enable this. This is your Revit example, the concept of a Revit central model. In the plant world, this would be a smart plant 3D database. Central nexus, people connecting to it. As the illustration is showing, some people will connect faster than others by nature of backbone infrastructure, cloud connectivity, etc. Depending on the mode of collaboration, this can be facilitated or potentially become a hindrance. The other approach in the BIM world is what we call a federated database. So it's kind of like the project is sliced and diced into a puzzle. We each take our piece of the puzzle, and then everything comes together as a whole. It's great. It's not emailing back and forth. We again have collaborative solutions that enable the synchronization of federated content. So the idea there is, you know, if I'm working in IBI and we have a sub-consultant working on structural, well, we got to share. So, you know, our session on BIM collaboration, we'll talk about some of the solutions that exist both to deal with centralized or federated approaches. And as I say in green there, often we have a hybrid where we're building our project, and the ability to achieve our BIM goals sometimes are dependent on having both approaches at play. I showed this last time, so just quickly, the recipe for success. You need all these pieces of the puzzle. So again, it's not just I need my training, but in this session today we talked about so far, we need our BIM lead in place. We definitely need to scope, and we need to be able to collaborate. So we just want to make sure that, you know, all those pieces of the puzzle are being thought about. And this slide again with the level of various dimensions. I wanted to show that, don't get hung up on the 5, 6, 7D, but this cyclone of a never-ending void of what you could possibly use BIM for. Keep that in mind, because there's a multitude of what you can do with BIM in support of this. It's about your data, it's about your assets. Your collection of assets is what makes up your model. In the design side, or at that top half, the construction side, the bottom right, but the O&M, the operation and maintenance, is really what it's about, and it's the life cycle of that asset throughout the duration. So very briefly here, the concept of the project BIM lead. I want to just put a teaser out there for a subsequent call. Regardless of a project, there's multiple disciplines, and I'm just showing some examples here. There'll be leads, so stamping professionals, designers, all under the realm of PMs, project managers, or design managers, or segment managers, or whatever the term is on your specific project. But this model, this heart of information that can potentially be used for various downstream purposes needs management and scoping. And that's what this project BIM lead role is. So we want to be able to have somebody that's there to help to guide projects to understand, what are you doing with that model? Do you know, can we define it? Can we set goals for the project, make sure we know why we're doing what we're trying to do, and then spend the duration supporting and ensuring quality and validity of the output and the progress, contractual deliverables, etc. So it's, for me, it's a very, very important role, and it has various acronyms or other names in the industry as well. I think that Project BIM Lead is the most resonating name today. I wanted to touch on this and stress the importance of project delivery. So, you know, that image, the triangle at the bottom, is from the project management training courses that are going on, but from the perspective of a BIM execution plan. So we've got templates that exist within the industry. So North America has Penn State, UK has the AEC or the CPIX, pre and post contract. So pre and post meaning what's happening during design, pre-sign-up, pre-tender, or pre-bid, and then as it goes through the duration of the life cycle. The plan can be formal and informal, but I would argue you just need a plan. I'm going to keep stressing, you just need to know what you're doing and why you're doing it. Heavily, heavily important. State your goals and which uses will be used to achieve the goals. You can use one BIM use for multiple goals. So let's say I want to use design review in order to help to ensure quality of my deliverables, in order to facilitate weekly project meetings, etc. So you can have various BIM project goals that take into account the use of design review. Ensure your goals are in alignment with project delivery. That's scope, schedule, budget, quality, risk. If it's not, it will not succeed. And what was described in the project management, which was great here, is if any one of the vertices of the triangle break, the triangle comes apart. Equally, if quality dwindles, the triangle will implode. If I'm spending so much effort to do the utmost of highest quality possible, it will explode because I'm not taking into account schedule, scope, and resources, which is cost and budget. So scope, schedule, budget all have to be in equal partnership with the application of BIM in order to facilitate and meet my quality requirements and mitigate the risk. They're all on the table. They're all convoluted and inherently tied to each other. Very important message. BIM cannot be in a vacuum when we're planning on projects. Level of detail. So while we're, think of the project delivery, we look at this and we say, okay, how do we define what our LOD is? And when I'm asked to do more, what do I do? So in recent times, I'll use the North American examples here, 100 to 400. They're not showing 500 in that circle there. But if you think of schematic, design development, 300 being contract document, 350 being fit for procurement or installation, and 400 being as constructed. Contractors have said to us, well, why can't you model to 350? There's nothing wrong. You have a model. It's just a little bit more. But the risk there, if something is fit for installation, so it's designed, it's detailed, connection details are in place, and it's been procured, and it's ready to be orientated in the building, in the facility, relative to the other installed components. That's beyond the designer. That's means and methods construction. So we always want to help to mitigate that, and we've done some dialogue back and forth where, if you look at the steel there, structural engineers will talk about connection details but won't design them. They get designed by the fabricator, stamped by the fabricator, and then delivered and assembled on site. So it's also, about levels of responsibility and liability. From a sheer using of the software, sure, I can model LOD 400 and above. But from a liability and why we're designing and thinking back to scope, schedule, budget, there's no reason to go above. Now, I say that with a grain of salt because there may be certain aspects. So if I put a little more detail on my door schedule would come out a little more robust. So there's some little tricks where you can fluctuate certain components, might have a little more stuff in there. But all in all, especially with contracts, we want to make sure that we're not asking for more or committing to more, sorry. The levels of definition in the UK, same concept, depending on the nature of the project. I like how this is shown, the illustration from brief and concept straight through to operation. Depending on how much information we are contracted to manage, include in our models, and portray outward, we've got to be very careful and understand what that means, and then portray our digital turnovers or prep our digital turnovers accordingly. So there's a lot of stuff in this slide, but I do like how they try to show the progression of information from brief through to operations. A couple examples of BIM goals. And these are taken from recent projects that I've been privy to. And you can see some of them. This is typical in a BIM plan. Is it high priority, medium priority, etc. And you can see the goal: creation of coordination, multidisciplinary 3D model with enough detail, etc. BIM uses that we would use: authoring, reviews, 3D coordination. So it seems pretty Some of them are obvious BIM goals, but we often state them to ensure that there isn't the expectation for more. Here, medium use of the BIM model to advance automation of cost estimation. And that's a good one, to advance the automation, not to produce the estimates. And I'd be curious to go back to this team to see if there was the expectation that the estimate audits all of a sudden became a push button. But we're helping to automate it, and that's an important piece as I read there. Quickly assess costs associated with design elements. You know, careful, just want to make sure that that's understood. Eliminate field conflicts, you know, maybe eliminate or reduce as much as possible, etc. So, you know, the carefulness of how these goals are written relative to the uses, just be very careful, but this is an idea of stating a goal and stating the BIM uses that would be used to achieve that goal. An example here is an LOD matrix, and this idea here showing, because it does find its way into our contracts where they'll say, okay, I want to bind you to say, you know what, if you're modeling strip footings, come issued for construction 100%, will be at LOD 300. Some items like conduits, it didn't show it lower in the spreadsheet, conduits, we might say, will only be at LOD 200 because we're going to say, yep, they're going to be plastic conduits, they're going to be field routed though. So I'm not going to state in the model where they are or show them. We're just going to show starting points and end points. So we want to be careful that we say that, yeah, some items will be 300, others won't. Some might say, you know, contractors might say, well, make this 400 instead. We might want to say no to that or plan for extra cost accordingly. On some of our civil projects, we've had some intriguing discussions on what does LOD 300 mean? So this here was actually a Viva project initially, and our contractor sat with us and said, well, we want you to model these, and this is what it kind of looked like on previous projects. So it was to help to build a comfort level over the level of detail and the expectation of what LOD 300 meant, so that as we started to produce our models, we were sure of a clearer understanding between us and the contractor. And obviously there's a lot to this slide here, but just wanted to show that it might be good, especially on VB or P3 projects, to sit down and go through some of these to say, hey, show me an example of an LOD 300 wall. Do you think of it in the same manner as I do? Very briefly here, this is because it's a global audience. Some of my examples, I don't know if you can see my cursor, but the first line AIA, so that's your PD, SDD, DCD. But for me, it's respect the schedule, respect the phases. So it doesn't matter what your delivery approach is, whether you're using feed for oil and gas, whether you're using the REBA 2007 or 2013, they all kind of align, in my opinion, to be exactly the same thing. And that's the important thing. If you looked at it simple, we all understand percentages. We're going to start at 0, we're going to finish at 100, we're going to construct and operate. That's common, different vernacular depending on your phases, but conceptually from a BIM perspective, if I show something that I'm saying it's schematic design, well, it applies to all of the phases down that column of 15%. So just understand the phases, the critical. And then at the end of the day, if you've done all of that, so you've identified your uses, you've built goals based on the uses that you're comfortable with or that you want to expand to do, you plan, you coordinate, you've identified what your software is, how many offices, how are we collaborating, you have a lead, so somebody who's accountable, you're looking at your scope, schedule, and budget, mitigating any risks with liability or putting too much in the model or data turnovers or interacting with contractors or operations. You've thought about your asset management if you have to turn over data to your owner based on your RFP. You're ensuring the quality of your deliverable, and that's your required deliverables, ensuring that BIM isn't causing an implosion to your PD triangle. You're staying connected to your team, and scope, schedule, budget, cost, quality, risk, everything's maintained. then you're doing awesome, and BIM can do no wrong. There's a lot of stuff there, but I just wanted to put that all to the forefront. Last slide here, this was actually something I saw on LinkedIn from NBS in the UK, and I thought how interesting this is. So they put together a periodic table of BIM, and there's a lot of good stuff. A lot of what I talked about is in here. Think about your, element 1 is your strategy, surveying, so your existing conditions, framework. I like how, software is number 15. That's the first place to talk about software. And the thinking process there is you've got to have some thoughts of 1 to 14 before you can decide on how you're actually going to achieve BIM on the project. So I thought this was pretty cool. I thought it would be a good way to end this particular session. So coming up in 3 weeks, we're going to try to do them on 3 weeks intervals. We're going to do BIM for architects, to specifically look at how the tool or how BIM as a whole can be utilized in architectural practices, equivalent for engineers, and we'll touch on GIS as well in that one, then get into spec construction, asset management, and I think prior to July, by July we'll be on the software one, and then we'll go from there. So if there are any questions, I'm going to just pop open the question box right now. And I know we're at the top of the hour now, so I do apologize for going the whole time. Okay, so yeah, there's a comment. LOD is also used as level of development, and that is true. There are actually different. When I talk about level of detail, that LOD 100 to 500. There's also the LOD level of development, and that's used more in the UK as well. They have an LOD 1 to 4, I think it was. I can't remember. So there are different vernaculars or different semantic meanings of some of these acronyms, and that just helps to sometimes convolute things, which is hard sometimes. Is there an app to use the BIM model on the iPad for site use? Yes, yes, yes. So it's fun. So there's a couple different approaches. So number one, we have to identify how you're BIMing. So are you in Revit, in Civil 3D, in a Bentley application, et cetera, et cetera, et cetera. So there's all the BIM authoring tools. Then we can take an approach to get it to something like BIM 360 Glue, which is an Autodesk application that can be used on an iPad. So BIM, I think it's the same name. If it's in Revit, there's an iModel plugin for Revit. I can then take it to Bentley's Navigator Mobile, which is a pretty slick app on the iPad as well. Graphisoft also has one. So long answer short, yes, we can get the model with information into the iPad or Android or Surface, and then depending on what you want to plug into it, then we can figure out what the best mobile app is, because if you're adding information, there may be other pieces that might have to be part of the puzzle in order to take your information, feed it, and send it back in. So BIM 360 Glue, we might need Autodesk BIM docs to take what you plug in as a punch list maybe and plug into their virtual environment. So there'll be some of that to do. Should we consider ProjectWise as a BIM tool or software? And I'd say ProjectWise is a BIM collaboration tool, so that'll be in the collaboration session later on in the coming months. So I think that will be, yeah, that's probably just before the summer. But it'll be one of the various collaboration tools that we talk about in that session. Do you feel BIM is taking over the need for having physical models? I want to say no. My answer to that is I think BIM is going to help to facilitate base contents to turn over to those who are building physical models. Now, if they're hand-built physicals, that's a different beast, but I'm thinking the 3D printing, laser cutting, and then assembly by physical model builders. I would say that's very much, like that specifically is a huge visualization piece. We're building that skill because there seems to be that need. But if it's hand building models completely void of BIM. I would also want to say no, because I would argue that's a form of art, just like hand sketching, and I don't think that would go away. So my argument would be is what would be the place for it in a specific project. So, okay, I think I got all this. Those who were saying that they couldn't hear me, hopefully that fixed itself and you could hear me. Just a reminder, so anybody else, anybody with an AIA number, please put it in the comments box. I'm not seeing any. For OAA and the others, you'll get a message based on the attendance records when your certificate is ready to be uploaded into the Con Ed systems. Make sure you've signed in if you're in a room, including your OAA numbers. And with that, thank you very much for your attendance. The next session, it's already scheduled on the IBIU website, and there'll be a webinar invite coming out probably in a week's time. So thank you, everybody. Have a great day, and hope you're able to attend the next session. Goodbye.